Section 4.2, Proportions. This video will help you write a proportion, develop proportional reasoning, determine if a statement is a proportion, and solve proportion. Start with writing a proportions. Let's take a look at a definition. A proportion is an equation that contains two ratios or rates that are equal. For example, if you work $10 per hour, then you should get paid $50 for 5 hours of work. These pay rates are the same, so they can be written as a proportion. And here's what typically a proportion looks like when we write it. So we have one rate right here, $10 per hour, is equal to our second rate, $50 for 5 hours. And when we write those two rates equal in an equation, we end up with a proportion. Proportions can be written three ways, but the fraction form is the most useful for our calculations. Here are the ways we're going to write a proportion. The first one we're already showing you there is that we write it, one fraction is equal to the next fraction. And that's the best way, and most of the time the most useful way for writing a proportion. However, sometimes we want to write these in an English sentence or statement, and so we'd use one of these two ways for that. We can say, 10 is to 1 hour as $50 is to 5 hours. And that's one way that you can read this proportion when it's written as a fraction. 10 is to 1 hour as $50 is to 5 hours. And then if we really want to shorten it here, we can write that out with colons, and it means the same thing. 10 is to 1 hour as 50 is to 5 hours. Let's take a look at an example now that will help you understand how to write an event as a proportion. Example 1. One box of candy costs $1.25. The candy is advertised as 2 boxes for $2.50. Write these events as a proportion. Well, see here we have one box of candy costs $1.25. And when we write a proportion, we want to definitely write the units in here. So I'm going to say that one box then costs $1.25. Now I want to write the other side of this rate here. Notice I have the units of box up top and dollars in the denominator. I want to write this other side as the same way, because if I don't write the same units, then there's no way these two rates could be equal. So then I would say up here, 2 boxes is to $2.50. Go ahead now and pause your video player and answer this practice question. When you're done, hit play to see how you did. Practice question 2. A 40-pound child received 2.5 milliliters of cough medicine. 60-pound child received X milliliters of cough medicine. Write these events as a proportion. Okay, well, if we're going to write something as a proportion, we know we have to have basically two rates or ratios equal. So I'll get my fraction bar set up there, and I'll say, okay, a 40-pound child, so I would write 40 pounds to 2.5 milliliters. All right, now I want to set this up on the other side. A 60-pound child, so notice I want to make sure I get those units in the numerator, since I wrote them this way over here, is going to receive X milliliters. Now, it would have been okay to switch this totally around and say 2.5 mLs is to 40 pounds as X milliliters is to 60 pounds. Either of these ways is totally fine. We just got to make sure that our units in the numerator and our units in the denominator match. Develop proportional reasoning. Proportions occur everywhere in daily as well as professional life. So it is important to develop proportional reasoning so you can quickly think through a proportional event. With a few simple techniques, you can learn to solve a proportion in your head and also estimate to see if a solution to a proportion is reasonable. All right, let's take a look at example 3 here to understand what I'm talking about. So solve this proportion in your head. 3/4 is equal to 9 what? Well, one way to figure this proportion out is just to figure out what the missing multiplier is. We're starting at 3, we're getting to 9. The missing multiplier there is going to be 3, and this is the same way that we built like fractions. So my missing multiplier here is going to be 3 over 3. And so you can quickly see then that n is going to be equal to 12. So now you get a little practice at this. You could do this in your head. You could just look at this fraction and go, okay, I'm looking for some sort of relationship here. The relationship between 3 and 9 is that's times 3. Multiply the bottom times 3, and you get quickly to the answer, so that 3/4 is equal to the proportion 9/12. All right, go ahead and pause your video player now and try practice question 4. And try to solve this in your head by figuring out what the missing multiplier is. When you're done, hit play to see how you did. All right, so we're going to try to solve this in our head. We're looking for the missing multiplier. 6 times what is going to get us to 24? Well, that's 4. So our missing multiplier here is going to be 4. And so then we're going to get n is equal to 28. Now we want to go ahead and write what this proportion is equal to. So we could say, 6/7, that's the same as 24/28. Now let's take a look at another example in practice that will help you solve proportions in your head using a different multiplier here. So example 5, solve in your head 10 over n is to 4 over 8. Now, when we look across the proportion this way, the relationship between 10 and 4 is not a very clear one. I mean, 10 I think is 2.5 times 4, which isn't really that clear to see. So we're going to look for another relationship here, another multiplication relationship here. And one of the other things we can do is look like this. We can look not just across the proportion, but we can compare numerator to denominator. And notice the relationship between 4 and 8 is that 8 is 2 times 4. So we can find the missing multiplier going from numerator to denominator as well. So if the missing multiplier on this right side is 2, that means the missing multiplier on the left side also has to be 2. And n here is going to be 20. So we get this, that 10/20 is the same as 4/8. Go ahead and hit pause now and answer this practice question. When you're done, hit play. All right, we're asking to solve this proportion, looking for the missing multiplier now from top to bottom. And in this case, we're going to start at the denominator and go back up to the numerator. And so it works either way. So we're thinking 2 times what is going to get me to 12? Well, the missing multiplier there is 6. On the other side, it will have to be the same if these proportions are going to be equal. So I'm thinking 8 times 6 is 48. And so we get this, 48 over 8 is the same as 12 over 2. Now we're going to put those skills to work here to see if a proportional answer seems reasonable. So let's take a look at example 7. Use estimation to determine if the statement is true. Well, let's take a look. Notice there's not a whole lot of relationship or an easy relationship to identify numerator and denominator here, but there is going across the proportions. And notice this is times 3 is going to get us 3, times 3 will get us to 9. That means if these proportions are going to be equal, I'd also have to multiply the bottom by 3, and that is just not the case. So since these don't have a common multiple going either direction, this is not going to be a proportion. So we'd say this is not a proportion. Go ahead and pause your video player now and determine if practice question 8 here, if this is a proportion. Okay, so taking a look here, if we look across the proportion, 75 and 7, that doesn't give us a lot of easy things to work with there. But if we look numerator and denominator here, 150 is twice 75. So really kind of we're multiplying by 2 to get this bottom number. And if you check this right side, it's the same thing. So this is a proportion. Go ahead now and pause your video player and answer these practice questions. Sometimes you're going to have to solve it in your head, and then other times you're going to use estimation to determine if the two ratios here are equal and give us a proportion. When you're done, hit play to see how you did. All right. Practice question 9. Looking for some sort of relationship here. Let's see. Not a good one across the fractions, but here it's times 3. So we want to multiply the other side times 3 as well. So that's going to give us that n is 45. All right, question 10. Not a good relationship going numerator to denominator, but across the fractions here, that is times 4. So whatever number I put up here would have to be 4 times as large as this one on the right. Well, 4 times as large, the way we get kind of back from that is to use division. So I can come up here and divide by 4 and get that n is equal to 10. All right, let's see. Looking for a relationship. Yep, here's a good one. 10 is twice 5. So another way to think about that going the other direction, it's going to be division. And so we're going to divide by 2. And so n is going to be 60. All right, let's see. Not a whole lot of good stuff going across, but you can see on this right side, That's times 4 to get the numerator. So the left side will have to be the same thing. So that would give us then that n is equal to 32. All right, 13. Now we're going to determine if this statement is a proportion or not. So let's see. The relationship, there's not a good one going across here, but top to bottom here, 15. That's 4 15s, I think, takes to get 90. No. 40 plus 20 is 70. 30, 60, 90, 6. So if you look at the relationship here, 15 to 90, we'd have to multiply by 6 to make that happen. And if we check on this side, 7 times 6 also gives us 42. So we're multiplying both numerators by 6. So this is yes. This is a proportion. All right, question 14. Not a lot of good stuff going numerator to denominator, but right here we can see this. 17 times 2 is going to give us 34. And then 1 times 2 is not going to give us 20. So this is no. This is not a proportion. 15. Let's see. 3 times 11 will give us 33. And over here, 10 times 11 will also give us 110. So yes, this is a proportion. 16. Let's see. 20 to 50. That's not a real clean one. 9 to 10. Not so good there. Let's see. 10 to 50. That would be times 5. Times 5 going this direction. 9 to 20. If I multiplied times 5 there, 9 times 5 is not going to give me 20. So this is no. There's nothing that's going to work there. So that's not going to be a proportion. So now we're going to take a look at a way to calculate and figure out the missing value in a proportion. That's typically what happens. Typically we have in a proportion, there's 4 values. We have 3 out of those 4, and we have to solve for an unknown value. While you can do a lot of these proportion problems in your head and kind of use your instincts to do this, a lot of times it doesn't work out real nice and clean. So we got to solve that. So now we're going to take a look at how we do that. And it's really simple. That if a statement is in a proportion, the rates or ratios in the proportion have to be equal in value. So one thing that happens here, and I've given you 2 equivalent fractions. 2/3 is equal to 4/6. These fractions are the same in value. Well, as it turns out, if the 2 fractions in this proportion are equal in value, then their cross products are also going to be equal. And let me show you what a cross product is. If I take this diagonal, that's where the cross part comes in, and I multiply it. 4 times 3, I get this product of 12. Now if I take the second cross product here, 2 times 6, I also get 12. So basically what happens in a proportion, if these 2 sides are going to be equal, then these cross products also have to be equal. So let's take a look at example 17 to understand this idea of cross products. So in 17, is this a proportion? Well, we could look here and we could use some estimation to figure this out, but sometimes we won't be able to do that. So let's look at these cross products. If this is going to be a proportion, then this diagonal, 30 times 7, is going to have to be equal to 42 times 5. So we'll put a question mark over the equal sign there because we don't know if those are equal yet. And let's figure these things out. All right, let's take 30 times 7. That's going to give me 210. And on this side, 42 times 5, let's see, that's going to give me 200 plus 10. Yep, 210 again. So sure enough, both of these cross products here are equal. That tells us that, yes, this is a proportion. All right, go ahead and pause your video player now and practice using these cross products to determine if this is a proportion. Okay, so we should be taking 1.4 times 5 on one side, and on the other side, 18 times 1.2. All right, so 1.4 times 5 gives us 7. 18 times 1.2 is not going to give us 7. It's going to give us 21.6. So since these cross products are not equal, we would say no. We'd say no, this is not a proportion. Solve a proportion. Proportions are useful for solving problems where something occurs at a known ratio or rate. For example, here's something. All of our screens now, or almost all of our screens, television screens and smartphone screens and tablets, they all have this aspect ratio of 16 by 9. And so what if we wanted to know, and basically what happens as we make larger televisions, we use this ratio 16 by 9 and scale it up to make the larger television screen, or if we're making something like a small smartphone, we would scale this down, but we always use that same ratio of 16 by 9. So if we wanted to know how wide an HD TV that is 36 inches tall is, we can use this 16 by 9 ratio to figure out how tall this TV has to be. So a proportion can be used to answer this question. To set this proportion up, we need to be mindful of two concepts and organize the information correctly. The first one is this, and this will happen every time we have a proportion. We are going to have a known ratio or rate. In this case, the aspect ratio of a television is 16 inches wide by 9 inches tall. Then we're also going to have an unknown ratio or rate. And now in the unknown ratio or rate, not both things are going to be unknown, just one. And like in this case, we know that we want our television to be 36 inches tall, and we're wondering how wide that has to be. The next thing we have to be mindful of is that the units in the ratio or rates must match. So notice here, 16 inches was the width, 9 inches was the height. We want to make sure when we set our ratio up on the other side, we follow exactly the same units. Width in the numerator, height in the denominator. Once we're mindful of that and we set up a proportion, now we can solve to determine the width of this television. And the way we're going to solve this, and the way that we solve proportions most of the time, is by using cross multiplication. So if these two fractions are going to be equal, this diagonal, 16 times 36, is going to have to be equal to this diagonal, 9 times n, which is just 9n. Now we have a simple little equation here to solve. So on the left side, 16 times 36 is going to give us 576 equals 9n, and then we divide both sides by 9. And let's see, n is going to be then 64. And in this case, since we're talking about the width of the television, we want to make sure we include units here. 64 inches. Go ahead now and pause your video player and practice using cross multiplication to solve this proportion. Okay, so we've got our unknown ratio or rate on the left and our known one on the right. Either way, our cross products are going to have to be equal here for this to work. So let's see. That cross product, 3 times 5, has got to be equal to this one, 6n. And so then we get 15 is equal to 6n. Divide both sides by 6. Let's see. On the right side, we're going to have n. On the left side, this isn't going to work out very cleanly, but this is written as a fraction, and we can simplify that fraction. So let's see. That would be divide a common factor of 3 out of there, and we would have 5 halves. That would have been a good answer. Or you could have had that n is equal to 2 goes into 5 2 whole times with 1 left over. So either 5 halves or 2 1/2 would have been a good answer for that one. All right, go ahead and pause your video player now and answer these next two practice questions. When you're done, hit play to see how you did. 21. Solve the proportion. Round your answer to the nearest tenth. Okay? So let's see. Let's take a look at this diagonal. N times 48. That's going to give me 48n is equal to this diagonal, 25 times 6. So 48n is going to be equal to, well, if I had 6 quarters, that'd be $1.50. So that's 150. Divide both sides by 48. Let's see, n is then going to be equal to, all right, we divide by 48, and we get this as our answer, 3.125. Now they want us to round this answer to the nearest tenth, which is this place value right there. So in this case, that's just going to be n is equal to 3.1. All right, practice question 22. The nursing program at State College accepts 3 out of every 10 students that apply. If 162 students get accepted, how many students apply? Okay, a lot of information here. Let's first look for our given or known ratio, because that is going to help us set this up. Notice 3 out of 10 get accepted. So 3 accepted out of 10 that apply. We're going to go ahead and write the words in here because that's going to help us make sure we get this set up right now. Notice what I want to have go right here is going to be the number accepted because I want my units to match in this proportion. So it looks like if 162 students get accepted, so that's going up here, we want to know then how many students, X students, apply. So there's our proportion. Now when I go to solve it, I'm not going to use these units in there. I'm just going to work with the numbers here. So if we look at this first diagonal, go in red here so we don't get this confused. This first diagonal then would just be 3x. And on the other diagonal, 10 times 162. Well, that's just going to be 3x is equal to, when I multiply by 10, all it's going to do is move that decimal place. So I'll get 1620. Divide by 3. Okay, and we see that 540 students applied. And since this is a story problem, we want to say what that number indicates. So 540 students applied. Go ahead now and pause your video player and answer practice question 23. When you're done, hit play to see how you did. To make lemonade, a recipe calls for 5 lemons to make 3 quarts. If Rashawn follows this recipe and uses 25 lemons, how many quarts of lemonade will he make? Okay, a lot of stuff going on here, but remember, if we're working in a proportion, first thing we're doing is we're looking for our known ratio or rate, and it's right here. 5 lemons to make 5 quarts. So let's write that down. 5 lemons to make, 3 quarts. Now I know over here I have to have the same units. Lemons over quarts. Let's see what they are. So if Rashawn follows this recipe and uses 25 lemons, then we want to know how many quarts of lemonade can he make. All right? Looking at our diagonals here, the first diagonal is going to be 5x is equal to 3 times 25. For my second diagonal, so I get this 5x is equal to 75. Divide both sides by 5. 75 divided by 5 is 15, and in this case we're looking for quarts. So 15 quarts of lemonade.